The distinctive metallic ping echoed across Red Beach. That sound would haunt Japanese soldiers for the rest of their short lives. October 20th, 1944. The clock read 10:15 hours. Late Take Gulf Beach in the Philippines was about to witness something unprecedented. Semi-automatic fire crackled like breaking thunder. The volume was staggering. The intensity was overwhelming. The relentless pace never stopped. 8 rounds fired. Reload complete. 8 more rounds unleashed. Japanese Imperial Army defenders had never experienced anything like this. Their ears rang with disbelief. Their hands trembled with fear. Their bolt-action rifles suddenly felt like museum pieces. American soldiers were firing as rapidly as Japanese troops could work their manual mechanisms. But the Americans never paused. They never hesitated. They never showed the fatal vulnerability that had defined infantry warfare for 50 years. The weapon creating this revolutionary storm was the M1 Garand rifle. General George Patton would later declare it the greatest battle implement ever devised. History was about to prove him right in the most brutal way possible. Japanese forces clutched their Arisaka Type 38 and Type 99 rifles. These weapons represented decades of refinement. They had served faithfully in previous conflicts. Today, they would prove tragically obsolete. The mathematics of combat were simple. Rate of fire determined survival. The side-firing more accurate shots in less time would control the battlefield. The Japanese were about to learn this lesson written in blood. Bringing 19th-century technology to a 20th-century gunfight was more than a mistake. It was a death sentence. The transformation of American infantry firepower had not begun on Pacific beaches. It started years earlier in quiet testing facilities. Springfield Armory in Massachusetts had been the birthplace of revolution. More than a decade before Pearl Harbor, visionary designers had been solving impossible problems. Their work would fundamentally alter how wars were fought. The weapon changing everything was born from a single insight. Modern warfare demanded rapid fire. The soldier who could shoot more often would dominate his enemies. John Cantius Garand was the man behind the miracle. This Canadian-born designer had dedicated his career to achieving the impossible. He worked for the United States Army. His mission was creating a self-loading rifle that could survive military service. Previous attempts had failed spectacularly. The French Monnier had been too complex. The Mexican Mondragon proved too fragile. The American Peterson was too unreliable for combat conditions. Every designer before Garand had faced the same brutal reality. Combat destroyed delicate mechanisms. Soldiers needed weapons that functioned in mud, sand, and blood. Garand spent years pursuing what military experts considered fantasy. His design was finalized in 1932. The United States Army officially adopted it on January 9, 1936. This made America the first nation to embrace semi-automatic rifles as standard infantry weapons. The M1 Garand operated on pure mechanical genius. Gas-operated systems had been attempted before. Rotating bolt mechanisms were known technology. Garand's brilliance was combining these elements flawlessly. When a round fired, propellant gases were diverted through a barrel port. These gases drove a piston that cycled the entire action. The spent cartridge ejected automatically. A fresh round loaded from the internal magazine. The hammer cocked itself. All of this happened in fractions of seconds. Ordnance Department specifications revealed the weapon's revolutionary nature. The rifle weighed 9.5 pounds unloaded. Overall length measured 43.6 inches. The .30-06 Springfield cartridge provided devastating stopping power. This was one of the most potent rifle rounds in military service. Effective range extended beyond 500 yards. Accuracy at those distances challenged any bolt-action rifle ever made. But the true revolution was rate of fire. 40 to 50 aimed shots per minute became the new standard. Skilled operators of bolt-action rifles managed 10 to 15 rounds per minute at best. The M1's internal magazine held 8 rounds. Loading occurred via an en-bloc clip that ejected automatically when empty. Critics worried about the distinctive ping sound alerting enemies. Combat would prove this concern meaningless. In battle chaos with multiple M1s firing simultaneously, individual reload sounds disappeared in the general mayhem. By 1941, when America entered World War II, production had reached 600,000 M1 Garand rifles. Springfield Armory and Winchester, repeating arms, were working at maximum capacity. By war's end, production would exceed 5.4 million units. This represented military procurement success on an unprecedented scale. Every dollar invested paid dividends in American lives saved. Every hour of factory time contributed to inevitable victory. Every technical refinement brought the weapon closer to perfection. The Japanese Imperial Army had made different choices. Their rifles represented evolutionary improvements over 1890s designs. The Arisaka Type 38 was adopted in 1905. The Type 99 appeared in 1939. Both were bolt-action weapons requiring manual operation between shots. Japanese soldiers faced an elaborate ritual with every shot fired. The bolt had to be unlocked and pulled rearward. The spent cartridge ejected manually. The bolt pushed forward to chamber a fresh round. The bolt rotated to lock position. Only then could the soldier aim and fire. This sequence consumed precious seconds. In combat, seconds meant the difference between living and dying. Japanese military doctrine had evolved around these weapons over decades. Training emphasized accuracy and fire discipline. The spiritual connection between warrior and weapon was central to Japanese military philosophy. The Arisaka rifles were excellent weapons by previous standards. They were robust, reliable, and accurate. They had served with distinction in multiple conflicts. But the Pacific War would not be fought by previous standards. October 1944 would demonstrate the brutal reality of technological warfare. The Japanese had brought inadequate tools to a gunfight that would determine the fate of empires. Strategic conditions reflected this technological disparity perfectly. General MacArthur commanded Southwest Pacific Area forces. He had promised to return to the Philippines. His invasion force for Operation King II comprised over 200,000 combat troops. These were battle-hardened veterans of the Sixth Army, under General Walter Kruger. Japanese defenders numbered approximately 260,000 troops. The 14th Area Army was commanded by General Tomoyuki Yamashita. This was the conqueror of Malaya and Singapore. His tactical brilliance was legendary throughout the Imperial Army. Yamashita's reputation would prove irrelevant. Superior tactics could not overcome inferior weapons. The most brilliant commander in Japanese history was about to be defeated by American industrial capacity. Japanese defensive preparations had been meticulous. They had studied American tactics in the Solomons. New Guinea campaigns provided valuable lessons. The Marianas battles revealed American weaknesses that could be exploited. Defensive positions were carefully prepared. Supply lines were established. Forces were positioned to contest every beach landing. Ammunition requirements had been calculated precisely. Counterattack routes were planned and rehearsed. The Japanese had prepared for nutritional warfare. They understood American tactics. They were ready for bitter fighting that characterized previous Pacific battles. What they had not calculated was the cumulative effect of firepower disparity. Every American rifleman could fire 5 times faster than Japanese defenders. Accuracy remained equal or superior. The mathematics of combat had already determined the outcome. Battles would be decided before the first shots were fired. Industrial capacity married to technical innovation was about to rewrite military history. Japanese technological conservatism would be paid for in blood and defeat. The price would be catastrophic. Tell us where you're watching from today. If this story moves you, subscription means everything to us. Tomorrow brings something extraordinary that you won't want to miss. Bolt-action rifle limitations had been understood since World War I trenches. Military theorists recognized the problem clearly. The side delivering more accurate fire faster would control battlefields. But tradition, budget constraints, and technical challenges prevented solutions. Nearly half a century of infantry combat was governed by brutal equations. Bolt-action rifles imposed firepower ceilings that could not be overcome. No amount of training could change this reality. Tactics could not eliminate fundamental constraints. Japanese Imperial Army experience with Arisaka rifles stretched back to 1904. The Russo-Japanese War had proven these weapons in combat. The Type 38 rifle, chambered in 6.55 50mm Arisaka, had served with distinction. Subsequent expansion in China and Southeast Asia confirmed their effectiveness. Japanese military philosophy elevated rifles to spiritual significance. The weapon was considered the soul of infantry. Discipline, training, and warrior spirit were expressed through marksmanship. This cultural emphasis produced exceptional shooters. Marksmanship training in the Imperial Army was rigorous beyond Western standards. Soldiers achieved remarkable accuracy under various conditions. The bolt-action mechanism had been refined over decades. It represented the pinnacle of late 19th century firearms technology. Arisaka actions were smooth and reliable. They functioned under extreme conditions. Tropical heat could not stop them. Arctic cold did not affect operation. Mud, sand, and saltwater exposure were overcome through superior design. Simplicity meant field maintenance required minimal tools. Individual components could show significant wear without affecting function. Japanese armories had perfected production techniques. Thousands of rifles could be manufactured monthly, using relatively basic machinery. But simplicity and reliability could not overcome fundamental operational constraints. Manual operation imposed absolute limits on rate of fire. A trained Japanese soldier under ideal conditions could fire approximately 15 rounds per minute while maintaining combat accuracy. This required perfect execution of complex manual tasks. The soldier had to acquire his target precisely. Aiming had to be perfect before firing. The bolt had to be rotated upward to unlock. Rearward bolt movement ejected the spent cartridge. Forward bolt motion chambered a fresh round from the internal magazine. Downward rotation locked the bolt securely. The target had to be reacquired because it might have moved during the cycle. Only then could the next shot be fired. Each shot required taking the rifle off target completely. Every bolt manipulation broke the sight picture. Each ejection and chambering cycle created vulnerability when the soldier could not return fire. These moments accumulated across firefights, battles, and entire campaigns. Squad-level engagements revealed the mathematical disadvantage clearly. 10 Japanese soldiers with Arisaka rifles could deliver approximately 150 shots per minute under optimal conditions. Reality was considerably worse. Combat stress affected firing rates dramatically. Movement requirements reduced accuracy and speed. Concealment needs limited optimal firing positions. Suppressive fire from enemies disrupted timing and coordination. Actual sustained rates were significantly lower than theoretical maximums. Japanese tactical doctrine had evolved around these constraints over decades. Infantry tactics emphasized fire discipline above rapid fire. NCOs controlled when subordinates could shoot. This prevented ammunition waste and maintained tactical coordination. Banzai charges were often misunderstood by Western observers. These were not fanatical death wishes. They were tactical responses to firepower limitations. When facing automatic weapons, prolonged firefights favored enemies with superior rates of fire. Charges attempted to close distance rapidly. Close combat might favor Japanese training in bayonet fighting. Hand-to-hand combat eliminated firepower advantages. But these tactics required reaching enemy positions alive. Japanese forces had attempted to compensate through crew-served weapons. The Type 92 heavy machine gun provided automatic fire support. The Type 96 light machine gun was more portable. But these weapons were heavy and required multiple operators. Machine guns became priority targets for American forces. Losing crew-served weapons meant losing most automatic firepower. American infantry maintained high fire rates even after support weapons were eliminated. Every rifleman carried semi-automatic capability. Pacific campaign experience had forced tactical adaptations. At Guadalcanal, Japanese night attacks attempted to negate American firepower through reduced visibility. Engagement ranges were shortened deliberately. Darkness might level the playing field. At Tarawa, elaborate fortifications channeled American attacks into predetermined kill zones. Concentrated bolt-action fire could be effective when enemies were forced into specific approach routes. But these positions were vulnerable to artillery and airstrikes. Saipan demonstrated defense in depth tactics. Space was traded for time, while maximum casualties were inflicted on attackers. Japanese forces could not win battles outright. They could only delay defeat while bleeding American forces. All tactical adaptations represented attempts to work around fundamental constraints. Japanese infantrymen could not generate sufficient individual firepower. Even superior tactical positions could not overcome rate-of-fire disadvantages. Perfect ambushes could be negated by American firepower recovery. Intelligence reports from units that had faced Americans documented problems clearly. Captured documents translated by Allied intelligence services revealed officer concerns about firepower disparities. One regimental commander from New Guinea stated enemy infantry maintain continuous rifle fire. Our soldiers cannot match this rate with manual weapons. Engaging equal numbers in open combat consistently produces higher casualties for our forces. Another document from the Marianas noted American rifles appeared to fire automatically. Each soldier generates firepower equivalent to 3 of our riflemen. Traditional fire superiority calculations no longer apply against this enemy. Japanese commanders were documenting problems they could not solve. Industrial capacity was already stretched by naval and aviation requirements. Shifting to semi-automatic rifle production was impossible. Suitable designs were not even available in quantity. The Japanese had experimented with semi-automatic weapons. The Type 4 rifle was developed late in the war. It was based on American gas operation principles, but it entered production too late and in too limited numbers. By 1945, when the first Type 4 rifles reached combat units, Japanese industrial capacity had been degraded by bombing. Only a few thousand were ever produced. The vast majority of Japanese soldiers would fight the entire Pacific War with manually operated rifles designed in the previous century. This firepower disparity had been compounding across hundreds of engagements. American forces had learned to exploit their advantages systematically. Tactics were developed that forced Japanese defenders into sustained firefights, where rate of fire decided outcomes. Marine and Army infantry training emphasized aggressive fire and maneuver. American squads could suppress enemy positions more effectively than opponents could respond. The stage was set for the Philippines campaign to demonstrate this advantage on massive scale. Every American soldier carried a weapon that fired as fast as he could pull the trigger. 8 rounds were available before reloading. 40 to 50 aimed shots per minute were achievable. Every Japanese soldier in defensive positions carried manually operated weapons. 5 rounds filled the magazine completely. 15 aimed shots per minute represented maximum performance. Combat mathematics had determined outcomes before battles began. The results would be written in blood across Philippine beaches and jungles. The M1 Garand's origin story began with vision rather than military requirements. John Cantius Garand was born in Quebec in 1888. He immigrated to the United States as a young man. Textile mill work provided his initial employment before mechanical design talent emerged. By 1919, he had joined Springfield Armory as a designer. The next 34 years would be dedicated to perfecting the weapon bearing his name. Technical challenges were formidable beyond description. Semi-automatic operation required harnessing fired cartridge energy to cycle actions automatically. This had to be accomplished without compromising accuracy, reliability, or durability under field conditions. Previous designs had failed because they were too heavy, too complex, or too sensitive to fouling. Military authorities remained skeptical that any semi-automatic design could meet combat requirements. Garand's breakthrough was the gas-operated rotating bolt system. Fired rounds generated propellant gases that were tapped from a port near the muzzle. These gases drove a long piston rod that cycled the operating mechanism. This system placed gas operation far from the chamber. Heat buildup was reduced significantly. Fouling in critical components was minimized. The rotating bolt locked into the receiver with multiple lugs. Secure lockup could handle powerful 30-06 cartridges, generating 50,000 pounds per square inch chamber pressure. Development consumed over a decade of testing, refinement, and evaluation. Springfield Armory records document hundreds of test firings under extreme conditions. Prototypes were subjected to temperatures from -40 degrees to +140 degrees Fahrenheit. Immersion in mud, sand, and salt water, followed by firing without cleaning, was routine. Heights onto concrete tested durability. Each failure led to design refinements. Every weakness was identified and eliminated through systematic redesign. By 1932, Garand had produced a design meeting every military requirement. The rifle functioned reliably after water submersion. Arctic cold and tropical heat were handled equally well. Accuracy was maintained after firing thousands of rounds without cleaning. Most importantly, sustained rates of fire exceeded any bolt-action rifle while maintaining combat accuracy at ranges beyond 500 yards. Ordnance Department formal testing in 1933 confirmed what Garand had achieved. This was genuine revolution in infantry weapons. Adoption moved with unusual speed for military bureaucracy. January 9, 1936, saw official designation as U.S. Rifle Caliber 30 M1. The United States became the first nation adopting semi-automatic rifles as standard infantry weapons. Other countries had experimented with semi-automatic designs. None had committed to full-scale adoption and production. The American decision reflected both design confidence and recognition that future warfare demanded higher rates of fire. Production requirements were staggering beyond imagination. Springfield Armory's initial capacity was approximately 100 rifles daily. Arming millions of soldiers would require massive industrial expansion. In 1940, Winchester Repeating Arms was contracted for M1 production. Additional production capacity came online rapidly. By 1941, with war approaching, both facilities operated at maximum capacity. Combined production exceeded 1,000 rifles daily. The manufacturing process represented American industrial capability at its peak. Each M1 Garand required precision machining of multiple components to tolerances measured in thousandths of inches. Receivers were forged from high-grade steel, then machined to exact specifications. Barrels were hammer-forged and rifled with 4 grooves. Careful gauging ensured dimensional accuracy. Gas system components required precise tolerances for reliable operation. Trigger mechanisms involved multiple small parts that had to function smoothly under combat conditions. Quality control procedures were exhaustive beyond civilian standards. Every rifle was proof-fired with high-pressure test cartridges before acceptance. Accuracy testing required maintaining specified group sizes at 100 yards. Function testing involved firing hundreds of rounds under various conditions. Rifles failing any test were rejected and returned for correction. Rigorous quality assurance ensured soldiers received weapons functioning reliably in combat. Logistical infrastructure supporting M1 deployment was equally impressive. The 30-36 Springfield cartridge required ammunition production facility modifications. En-bloc clip loading systems required manufacturing millions of 8-round clips. Training programs taught proper maintenance and operation to countless soldiers. Spare parts pipelines were established worldwide. Armorer training programs expanded to ensure field-level maintenance capability. By December 1941, when America entered World War II, approximately 600,000 M1 Garand rifles had been produced. This gave American forces initial advantages, though not all units were equipped immediately. National Guard units and some Army divisions still carried bolt-action M1903 Springfield rifles, but production was accelerating rapidly toward full deployment. By mid-1943, M1 Garand production exceeded 100,000 rifles monthly. By war's end, total production reached 5,468,772 rifles. This represented one of the most successful weapons procurement programs in military history. Weapon specifications reflected revolutionary capabilities that would change warfare forever. The M1 Garand weighed 9.5 pounds empty and was balanced for rapid target acquisition. The 30-06 cartridge delivered 2,800 feet per second muzzle velocity. Flat trajectory and excellent accuracy at extended ranges were the result. Gas-operated systems cycled at approximately 600 rounds per minute theoretical rate. Practical combat rates were 40 to 50 shots per minute. Effective range extended to 500 yards for point targets. Area targets could be engaged at 800 yards with effectiveness comparable to or exceeding bolt-action rifles. Combat loading procedures were elegant in their simplicity. Soldiers pushed 8-round en-bloc clips into internal magazines from the top. Bolts automatically closed and chambered first rounds. After firing 8 rounds, empty clips ejected automatically with distinctive metallic pings. Bolts locked open ready for immediate reloading. Trained soldiers could reload in under 3 seconds. This speed, combined with semi-automatic operation, meant American riflemen maintained sustained accurate fire at rates previously achievable only with machine guns. The M1 Garand represented more than technological innovation. It represented American industrial philosophy applied to warfare. Where other nations sought incremental improvements to existing designs, American designers and manufacturers created something fundamentally new. Where other nations hesitated to commit resources to unproven technology, American industries scaled production to equip millions. The result was a weapon proving decisive in combat across every theater of World War II. Nowhere would this be more dramatically demonstrated than in Philippine Islands, where Japanese forces armed with bolt-action rifles faced the full weight of American semi-automatic firepower. If you're enjoying this detailed account, make sure to subscribe to our channel. Preparing and researching these stories requires considerable time and effort. Your support means everything to us as we continue bringing you these remarkable historical accounts. The firepower advantage demonstrated at Leyte created ripple effects throughout the Pacific War's final year. Military planners had theorized about semi-automatic rifle advantages, but never proven them at this scale. Within weeks of initial landings, frontline reports confirmed what had been theoretical. Semi-automatic rifles provided such decisive advantages that they effectively multiplied American infantry strength by factors of 3 to 5 in direct combat engagements. By November 1944, Japanese Imperial Headquarters in Tokyo was receiving detailed analyses from commanders throughout the Philippines. These reports were later captured and translated by American intelligence services. They revealed cascading psychological and tactical effects of firepower disparity. One classified assessment from General Yamashita's staff stated, "American infantry weapons represent fundamental advantage in all direct engagements. Our forces cannot achieve fire superiority regardless of tactical position or numerical strength. Conventional defensive tactics are ineffective against this firepower." Psychological transformation was more significant than tactical implications. Japanese soldiers, indoctrinated with Bushido warrior code, emphasizing courage and aggressive spirit, found themselves in situations where these qualities provided no advantages. Brave soldiers with Arisaka rifles charging American positions were cut down before closing to effective range. Disciplined soldiers maintaining defensive positions were suppressed by fire volumes they could not match. Spiritual and cultural foundations of Japanese military effectiveness were being negated by industrial technology. American tactical innovation accelerated throughout the Philippines campaign as commanders learned to exploit firepower advantages. Marching fire techniques, where advancing infantry maintained continuous fire while moving toward enemy positions, became standard practice. This tactic was impractical with bolt-action rifles requiring soldiers to stop and manually cycle actions. With M1 Garands, it was devastatingly effective. Japanese defenders faced walls of advancing American soldiers, each firing repeatedly. Psychological pressure broke defensive cohesion before physical contact occurred. American squad tactics evolved to reflect weapon capabilities. Squad leaders orchestrated fire from 8 to 12 riflemen, each capable of sustained rapid fire. Overlapping fields of fire made Japanese counterattacks suicidal. Traditional emphasis on machine guns as primary sources of squad firepower diminished. While machine guns remained important, M1 Garands ensured rifle squads maintained formidable firepower even when separated from crew-served weapons. Medical records from Navy hospital ships treating wounded from the Philippines campaign documented another consequence of firepower disparity. Japanese casualties showed much higher ratios of killed to wounded compared to previous campaigns. Medical analysts attributed this to volume of fire effects. Japanese soldiers were being hit by multiple rounds in engagements, reducing survival rates significantly. American casualties conversely showed improved survival rates as superior firepower allowed faster casualty evacuation and better position security during medical treatment. Campaign statistics told the story in stark numbers. By the time organized Japanese resistance ended in the Philippines in mid-1945, American forces had killed approximately 336,000 Japanese soldiers, while suffering 62,000 casualties themselves. Kill ratios, while influenced by many factors including air superiority and artillery support, reflected fundamentally unequal ground combat. In infantry engagements specifically, American forces consistently inflicted casualties at rates 3 to 5 times higher than they received. Japanese attempts to counter firepower disadvantages grew increasingly desperate as campaigns progressed. Some units attempted mass nighttime infiltration attacks, hoping darkness would negate American firepower advantages. These tactics achieved occasional local successes, but ultimately failed. American forces adapted by establishing defensive perimeters with overlapping fields of fire. M1 Garand rates of fire remained effective even in limited visibility conditions. Distinctive muzzle flashes of 30-06 cartridges actually aided target identification for other defenders. Other Japanese units attempted to avoid direct combat, entirely reverting to guerrilla tactics and ambushes. Even these approaches proved ineffective against American firepower. Ambushes required inflicting rapid casualties before enemies could respond effectively. American forces generated suppressive fire so quickly that ambushing units found themselves pinned down and overwhelmed before achieving objectives. Implications extended beyond the Philippines into planning for proposed invasion of Japan. Operation Downfall incorporated assumptions about firepower advantages that M1 Garands provided. Military planners calculated that semi-automatic rifles effectively multiplied American infantry strength, reducing numerical superiority required for successful amphibious assaults. Joint Chiefs of Staff documents indicated planners believed one American infantry division equipped with M1 Garands was equivalent to 1.5 to 2 divisions equipped with bolt-action rifles in combat effectiveness. Japanese military leadership recognized implications clearly. Post-war interrogations of senior Japanese officers revealed many had concluded by early 1945 that conventional military resistance was futile. Combination of American air superiority, naval dominance, artillery firepower, and infantry weapons superiority meant Japanese forces could not win battles. They could only delay defeat while accumulating casualties. Some historians argue this realization influenced Japanese leadership's eventual decision to surrender, although atomic bombings and Soviet entry were obviously decisive factors. M1 Garand influence extended into post-war eras and subsequent conflicts. The rifle served as standard American infantry weapon through the Korean War, where it again demonstrated decisive advantages against opponents equipped with bolt-action rifles and early semi-automatic weapons. Veterans of both World War II and Korea consistently rated the M1 Garand as the finest infantry rifle of its era. General George Patton's assessment as the greatest battle implement ever devised became the weapon's enduring epitaph. Technological lessons were absorbed by military establishments worldwide. By the 1950s, every major military power was developing or adopting semi-automatic or automatic rifles. Bolt-action rifles, dominant for 70 years, were relegated to specialized roles like sniping. M1 Garands demonstrated that in modern industrial warfare, the side with superior technology and industrial capacity to deploy it at scale would dominate battlefields regardless of numerical strength or tactical positioning. Human costs of technological disparity were staggering beyond comprehension. Hundreds of thousands of Japanese soldiers died in combat against American forces throughout the Pacific War. Many were brave, well-trained, disciplined soldiers whose primary disadvantage was inadequate equipment. M1 Garands saved countless American lives by providing overwhelming firepower advantages. But they also inflicted catastrophic casualties on enemies unable to respond effectively. Today, the M1 Garand occupies a revered place in military history and American culture. Rifles appear in museums and are cherished by collectors. They remain popular among target shooters for accuracy and reliability. Veterans organizations maintain weapon memories through annual ceremonies honoring those who carried them in combat. The distinctive ping of ejecting en-bloc clips remains one of the most recognizable sounds of World War II. Beyond nostalgia and historical interest, M1 Garands represent fundamental truths about modern warfare. Victory belongs to the side that can deliver the most effective firepower most efficiently. John Garand's design, American industrial capacity, and soldiers who carried weapons into combat combined to create systems that decided battles before they began. Japanese forces discovered on beaches of Leyte and in jungles of the Philippines that courage and training could not overcome simple mathematics of firepower. 8 rapid shots versus 1 slow shot repeated millions of times across hundreds of engagements accumulated into inevitable defeat. The story continues with 2 more outstanding historical accounts waiting for you right on your screen. If this one resonated with you, these next stories will be equally compelling. Just click to discover them. Don't forget to subscribe and activate notification bells so you never miss our uploads. Your support enables us to continue bringing you these fascinating glimpses into history's most remarkable moments.